Alex Howard from O'Reilly Media. Welcome back to our live stream here from the Strata conference floor. With me I have Dwight Merriman, now the CEO of 10Gen. I first got to become familiar with your work as the former CTO of DoubleClick. As people know, does fairly large-scale internet advertising. And in that context, I think you said that you handle something like 400,000 ads a second.
Yeah.
Now that's big data. What happened in terms of looking at that problem that led to the creation of MongoDB?
Right, so there's a lot of data when you look at these big internet infrastructure systems, and we saw that at DoubleClick, we see that at Google, et cetera, where there's been a need to build new things. Conventional databases are great at a number of things, but beyond a certain scale, you need to do something else. So we had that problem then, and so what we're trying to do now with MongoDB is kind of solve that problem once for everyone, rather than you have all these companies building one-off solutions.
Now, the name seems straightforward. Mongo is big, DB database. Is that about the right?
Yeah, so Mongo is the middle of the word humongous. So that was the sort of little origination of the name.
Okay, just wanted to make sure I get that part of it right.
That's right.
I wondered these things. Sometimes there's some pretty wacky names in the tech industry, but that one made some sense.
Yeah.
So what are the most important ways that MongoDB has grown and changed since 2007?
Well, the first thing is just that the usage is growing very fast. So there's over 100,000 downloads a month of the product. There's a lot of users, many thousands and thousands of deployments, both startups and big companies, Fortune 500, Worldwide 500 companies, SAP and Disney are using the product now. So it's great to see because it's going to fit into the mix, whether it's big companies or small companies in terms of their data architectures, I believe.
Now that's quite a bit of diversity in terms of the range between the sizes of organization. Does that mean that it's a good fit for every organization, or is there some things that don't quite work in that context?
It's a good fit for every organization, but it's just a question of for what. Because it's sort of, if I ask you, who should be using a relational database, big companies or small companies, well, you say, well, they should both use it. And then it's just a question of for what, right? So I think there's an explosion of data, like information explosion going on. So everyone's going to have a lot of data. I think sometimes if you don't think you have a lot of data, it's just because you haven't stored it, right? Because it was too expensive or too difficult. So we're seeing that now. And in addition, some of these new tools like MongoDB, they also make it easier to write code where the backend is a database in some cases. So we have two reasons people like the product. One is just the horizontal scalability, which fits in well with cloud computing, where you have lots of sort of medium-sized machines instead of one giant machine. And in addition, it's sort of about agile development. Can I write code quickly? Does it fit well with agile development methodologies, which are very popular these days too?
Okay. Now, so you look at the different uses, the whys, so to speak, and then the whats. What are some of the ways that more innovative, or maybe ways you didn't expect people to deploy it?
Yeah, so people using the product to in real time do very high volumes reads and writes from web app servers. That was sort of the first use case and very common. I think another one that's kind of a no-brainer is kind of using it to build up a content management system. That kind of data fits in it really well. There's a lot of use cases though, whether it's mobile software, where things like geospatial fit well, gaming. But in addition to that, I think one of the ones that surprised me the most was using it to archive data from a relational database. And Craigslist is doing that. So they have a database with their posts for today, and just kind of a continually rolling set of active posts. They didn't keep all of them forever, because they need to, and an archive database. And they've moved that archive database to MongoDB. It is a very large database. But sort of the fascinating thing is that you're backing up, or archiving, rather, a relational database with a non-relational database. And the other thing that is really fascinating about it is it actually turns out to be a great solution. Because if you think about it, if you're going to archive a relational database, what do you do when the schema changes? Right? Because I can change the schema, but if the schema is sort of a moving target temporally, how does the archive work? If I drop a column, you don't want to drop the archive values for that column. or if you make other transformations in the schema, that's tricky. So with some of these new tools like MongoDB, they're very flexible schema, so they can handle that gracefully. But it's a kind of counterintuitive example.
Now, you mentioned tools. The exaflood, right? One of the great terms coming out of this, the idea that there's just a rapidly increasing amount of data that's rushing in. This is one of the tools that's helped with that. What in the larger context, what tool is there in the larger context that doesn't exist yet that needs to get built?
Well, I think these NoSQL quote unquote tools they're new. So I think they just got to build out a lot and become ubiquitous and have much larger ecosystems, lots of client-side software that works with them out of the box. So that's one thing. I think one thing you're going to see, I think, is a lot of emphasis on building things with a lot of intrinsic parallelism as we go forward, because computer architectures are changing such that you have to have that. So for a long time, clock speeds on CPUs cores were going up. That's not really happening now, but what is happening is Moore's law is still happening, right? So you can't get a faster CPU core anymore, but I can give you 1,000 really cheaply. But you can't take a traditional program and run it on 1,000 or 10,000 cores without a lot of work. And the data layer of the stack is actually where the most challenges have existed with this parallelism. I mean, app servers, it's pretty easy to add 20 more app servers, right? But other aspects of the stack, not so easy. So I think you're going to see a lot of changes in tech that have to do with that parallelism. MapReduce is a good example of that. It's something which scales horizontally very well, deals with parallel compute capacity very well. But I think you'll see more things like that too.
Okay, well, Dwight, thank you very much for dropping by. I know you've had a pretty intense day, and I gather you're going to be talking once more before the end of the day too, right?
Yeah, okay. Last session today.
Cool, well, good luck.
Thanks.